When they are transforming from microservice to from monolith to microservice, or they are starting from scratch from microservices, the purpose is to have smaller independent services that are easier to manage. They are owned by the teams, and of course maintained by them. The purpose is that the owning team is responsible for the quality of the owned component or microservice. So in practice, it looks something like this. So you have multiple components, and they usually go with a weak code ownership, which means that even though the components are assigned to teams, other developers from different teams can contribute to the components. But the responsibility is still on the owning team. Now, since other developers can contribute to each other members' components, I think, okay. Javier, you can still hear us, right?
Javier, can you still hear? Can you give us thumbs up?
Yes, I can hear you.
Okay, it's Parisa, I think.
Yeah.
Okay. Sorry. As I was mentioning, the contribution can come from other members of members of other teams, and in some cases, the contribution can be a little bit higher than the contributions of the owning team. This can be for different reasons. Say, if there's a restructuring and someone moves from one team to another team, and they have kind of a backpack and a baggage to carry with them, they need to still contribute to the previous component. Now, we never have, or rather we rarely have 100% contribution from the owning team, and we usually end up in some sort of a spectrum of how much contribution you have to a component. The more you are to the right side, the more responsibility diffusion you have. What we mean by responsibility diffusion is that when you have many minor contributors, nobody tends to care about the code. And it may impact the code quality because you have a high risk of defects. This is also true in the components that are more like components that are used by other teams more often. For example, if you have a microservice or a component that deals with users, all other teams are also dealing with that. This is such example of one of the components that we have studied. Here you see one microservice with different classes. Technically, the component is owned by the team purple here, but you can see that there are many other colors, meaning that other teams are contributing to those much more often than the owning team. So that was more or less the context. So what we hypothesize is that if you have more contribution to a component that is coming from outside of the owning team, the figure here on the left, you have lower alignment between your ownership and contribution. On the other hand, if you are the main contributors to your own component, you have higher alignment. And what our hypothesis is that if the owning team does not have a major contribution, they will have a lack of sense of responsibility, which will lead to faster accumulation of technical debt. So this is the hypothesis and what we are going to check. So to check this, we did an embedded case study with a large software development company. We did the study on one big system, which is over 1.5 million lines of code. There are 20 teams that are developing this one. We selected 10 components that belong to one team. This wasn't planned, but at some point during the analysis, the team split into two, and they divided the components between them who's taking care of. We did the analysis for the period of 3 years, from 2020 to end of 2022. They collected, so the data is collected for every week. So at the end of every week, we have the data collection for TD and the other measurements that we are collecting. And of course, we performed the statistical test to check if there is a correlation between the alignment and the changing of TD. So what we are looking at is the two main constructs that we have, which is the contribution degree. It is a shorter version of saying for us the alignment between contribution and ownership. And of course, we have technical debt density. Technical debt density would be the normalized TD that allows us to compare different components, because you cannot directly just say one component has higher level of TD, because there are other aspects to that as well. And for contribution degree, we are using a model that we published before, and it uses code production, pull requests, and tickets to calculate how much contribution is done from a certain team to a component. Now, I already mentioned that the team split during the analysis period. So we started with the blue team, and they were working as one unit until somewhere in the beginning of 2021. And then they split into two. Of course, there were members that were joining the team, either new recruitments or leaving the teams from changing the companies. Right. So now looking at the graphs that we have, I will show you a bigger one, but just to cover the colors and the figures, here we present two things. The technical debt density, which is the solid line for each of the components, and the contribution degree, which is the dashed line. We also represent the before the split and after the split with blue and orange colors. So what we first observe is that in almost all the components, and I hope that this works. No, it's not working. So there is a drop of ownership, a contribution degree as soon as the team splits. So you can see that in C1, you can see that in C2, C3, and many others. There's also other significant drops that are related to, for example, architect leaving, product owner leaving, and other events as well. So what we wanted to do was to see whether there is a correlation between technical debt density and contribution degree. This is the scatter plot. I will bring examples from, or other observations from each component. I just wanted to here to mention that we didn't do a regression, and this line here is only for visual inspection to see how things are working. Now, just to mention that the colors are the same. So the blue ones represent before and the orange ones represent after. Now, just to give you some highlight of the results, of course, as I mentioned before, there is a drop in contribution degree as soon as the team splits. It seems normal because the team members are now different. The obvious thing that we were expecting was to see if the contribution degree increases, we have a decrease in technical debt density, and you can see that quite clearly in this figure. Now, second, I wanted to mention the cases that are not dropping with the contribution degree. C8 here is a new component. It was created like a few weeks before the team split. Therefore, we don't see that much of a change in the contribution degree. However, somewhere after week 100, I think there was a senior developer and the product owner that left the company, and then you have this huge drop of contribution over there. In the scatter plot, you can see the same thing of clustering the effect that we have on the left side and the right side, and it corresponds to this observation. Now, the last one, what we have also observed is that whenever the contribution degree drops below 40, the TD kind of just goes haywire. 40 is not a magic number, it's just that what we have observed visually inspecting the graphs. Now, so as to the main results, we know that, of course, we observed in 8 components out of 10 that when the team split, we had the drop in contribution degree, which was expected. The other 2 components that were not in this were either created close to the split or after the split. So the components that we observed, all the components that their responsibility, their contribution degree dropped below 40%, which were C2, C4, C6, and C10, that's a typo there, exhibited a weird increase in TD after the drop to below 40%. Now, the bulk of the results that we have are the correlations. So in many cases, we see a correlation between contribution degree and TD density, and they are significant. Interestingly, of course, a negative correlation would be more desirable, because as the contribution degree increases, you expect to see a decrease in technical density. And before the split, for the significant results, we see that negative correlation. However, after the split, we see also significant results in most of the cases. However, we have sometimes positive correlations. And the positive correlations are C2, C4, C6, and C10, the ones that dropped below 40%. C8 here is a different story because it's a component that was created after the team split, and I will get back to that. Of course, these components that have positive correlation also suffer from architectural knowledge vaporization, which translates to senior members leaving the team that impact the general state of technical knowledge. Now, so the implications of what we have done is that, of course, contribution degree should be taken into account when you're assigning ownerships of the teams, of the components to the teams, especially if you are going through an organizational restructuring. The contributions of senior members are also important to preserve code quality, and a high contribution alignment helps keeping TD under control. Now, getting back to the weird case of C5, sorry, I think, again, I might have had a typo in the previous slide. So the reason we have an increase in technical debt while the contribution degree is high here is that what we call the technical credit, which means that the senior members of the team at the early stages of the development can take on more technical credit because they know what they are doing and they plan to pay it later back. And higher ownership also can be linked to more technical credit. Now, interestingly, we are still, of course, continuing to work with the same team and the same components. I think it was less than a month ago that they decided to merge again the same 2 teams back together. So we would like to see what happens after that. We are continuing collaborating with the same team and company, and we are looking into also other factors that definitely will impact our observations as well. So I think that should be it.